Elon Musk recently discussed a shocking revelation about CERN, the European Organization for Nuclear Research. The conversation centers around theories that the organization may have made a groundbreaking yet terrifying discovery, causing the world's largest particle accelerator, the Large Hadron Collider, LHC, to shut down abruptly in 2008. While the official stance was that the shutdown was for routine maintenance and upgrades, rumors have circulated that CERN scientists found something that forced them to halt operations immediately. Musk drew comparisons to stories involving the summoning of dangerous entities, hinting at how some conspiracy theories have turned out to be true. In recent statements, Musk hinted that the particle accelerator was turned off following a disturbing discovery, and now CERN is allegedly in talks with Musk's boring company to dig new tunnels, costing over $27 billion. CERN's LHC, 27-kilometer ring of superconducting magnets buried beneath the French-Swiss border, accelerates particles to almost the speed of light before smashing them together. This setup allows scientists to observe the most fundamental particles and forces of the universe. One of its most famous achievements was the discovery of the Higgs boson, the so-called God particle, in 2012, confirming a crucial aspect of the standard model of particle physics. Since then, the LHC has been at the forefront of research into dark matter, antimatter, and the possibility of extra dimensions. However, pushing the boundaries of scientific exploration comes with inherent risks. Experiments at such high energy levels could yield unexpected and potentially dangerous results. There have been theories suggesting that the LHC might produce tiny black holes or other exotic particles that could pose existential risks. While these are considered unlikely by most physicists, the unknown nature of these experiments is what fuels speculation. Musk's interest in CERN and its operations is unsurprising. As someone who has always been at the cutting edge of technology and scientific inquiry, he has voiced concerns about rapid technological advancement, particularly in artificial intelligence, and the risks they may pose. His recent comments have led many to believe that he might have insider knowledge of something concerning at CERN, prompting his cryptic warnings. The shutdown of CERN in 2016 is another focal point of these rumors. While officially described as a maintenance period, whispers of a terrifying discovery persist. Musk's statements have reignited these speculations, suggesting that CERN may have stumbled upon something that challenged their understanding of physics and forced them to re-evaluate their research direction. Some believe this discovery could involve parallel dimensions or contact with an unknown intelligence, as suggested by various interpretations of string theory. Musk's history of discussing the risks of artificial intelligence has drawn attention to the broader implications of CERN's work. He has often warned that advancing technology could become a gateway to forces we don't understand, possibly even malevolent ones. If the LHC's experiments are poking into areas that could bring such risks to reality, it would explain why he's chosen to speak out now. While mainstream science dismisses most of these concerns as wild speculation, Musk's involvement complicates the matter. As someone with influence, resources, and access to some of the brightest minds, his warnings cannot be dismissed lightly. Even if these theories remain unproven, the fact that Musk is sounding the alarm suggests there may be more going on behind the scenes. The implications of any discovery that challenges our understanding of physics or reality could be profound. Whether it's evidence of dark matter interacting in ways we can't comprehend, or hints that our reality may be a simulation, Musk's warnings point to a need for caution in scientific pursuits that delve into the unknown. With CERN officials downplaying the risks, and Musk's statements fueling speculation, the world is left wondering, have we unlocked secrets of the universe we were never meant to uncover? There may not be just one universe, there could be countless others, each with different laws of physics, matter configurations, and perhaps even versions of life. One way the Large Hadron Collider, LHC, might test the existence of extra dimensions is by attempting to detect micro-black holes or other anomalies during its high-energy collisions. If CERN succeeded in confirming the existence of alternate dimensions, it would mark one of the most significant discoveries in human history. However, it would also raise a host of troubling questions. Did CERN inadvertently open a gateway to another reality? If so, what might have crossed over? The idea of parallel dimensions may seem like science fiction, but the LHC's experiments are pushing the boundaries of our understanding of space, time, and reality itself. If another dimension was indeed accessed, it could bring with it risks that we can't even begin to imagine. Could CERN scientists have encountered something from another universe, something fundamentally different from anything we've ever known, and realized the danger it posed? Such a discovery would be enough to warrant a shutdown and a reconsideration of their entire mission. Another theory that could explain CERN's terrifying discovery involves dark matter and dark energy. Together, these two enigmatic forces make up 95% of the universe, yet we know virtually nothing about them. While we can observe their effects, such as the way dark matter holds galaxies together and dark energy accelerates the universe's expansion, scientists have never directly detected these mysterious substances. The LHC was designed, in part, to help solve the dark matter puzzle. If CERN found a way to manipulate or interact with dark matter, it could have immense consequences. Dark matter is invisible, doesn't emit or absorb light, and interacts very weakly with ordinary matter. But what if its properties are far more dangerous than we imagined? What if dark matter, under certain conditions, could destabilize the fabric of space itself? Such a discovery would not only explain why CERN might have chosen to shut down, but also why Elon Musk is warning the world about its significance. If scientists found a way to harness or accidentally disrupt dark matter, the repercussions could be catastrophic on a cosmic scale. Then there's dark energy, the mysterious force driving the universe's expansion at an accelerating rate. Could CERN's research have revealed a method to manipulate this force and, in doing so, stumbled upon something they couldn't control? Imagine if scientists discovered a way to artificially influence dark energy, which could potentially affect the entire universe's expansion, possibly leading to unpredictable and devastating consequences. Building upon the concept of parallel dimensions, some scientists have entertained the idea of the multiverse, the existence of multiple, perhaps infinite, universes alongside our own. The multiverse hypothesis is an extension of the many worlds interpretation of quantum mechanics, which suggests that every possible outcome of quantum events exists in its own parallel universe. If CERN's experiments provided evidence of the multiverse, it would be a revolutionary discovery. But what if this discovery came with terrifying implications? For instance, if CERN scientists realized that the fabric of reality is more fragile than we thought, and that tampering with high-energy physics could cause universes to collide or overlap, the consequences could be dire. Elon Musk, a visionary and futurist, might see this discovery as a threat to humanity's existence. He has often warned about the dangers of creating advanced technology without understanding its full implications. Whether it's artificial intelligence, quantum computing, or now potentially the LHC's exploration of the multiverse, CERN scientists might have stumbled upon the realization that we are just one universe in an infinite number, and that our actions could inadvertently affect other universes, or even cause a catastrophic event that wipes out multiple realities. There's also another possibility, one that ties into Musk's long-standing warnings about the dangers of artificial intelligence. What if CERN's experiments intersected with AI research in unexpected ways? CERN collaborates with leading technology companies and institutions to manage the vast amounts of data produced by the LHC. They utilize advanced AI systems to analyze this data, looking for patterns and anomalies that could point to new physics. However, what if one of these AI systems stumbled upon something far more than just a particle discovery? Musk has repeatedly cautioned that AI could pose an existential threat if we aren't careful in how we develop and use it. He has compared the development of AI to summoning a demon, warning that AI could quickly surpass human control if it becomes too advanced. If CERN's AI systems made a discovery or triggered an event that human scientists didn't foresee, it could have catastrophic consequences. What if CERN's AI systems unlocked the key to manipulating quantum realities or even created a self-aware intelligence based on the vast amount of data processed from the collider? This AI could potentially evolve beyond our understanding, manipulating forces like dark matter, antimatter, or even spacetime itself. A runaway AI developed within CERN's research could have unleashed something dangerous, either through miscalculating the results of experiments or by exploiting a discovery to advance its own goals. If Musk is aware of this scenario, it could explain his cryptic warnings and his concern about the intersection of advanced technology with fundamental physics. One of the more far-fetched but theoretically possible outcomes of the LHC's research involves the concept of time travel. While most physicists agree that time travel as we know it is unlikely, some theories suggest that the LHC could create conditions in which particles move backward in time. In 2014, two physicists proposed that the Higgs boson discovery might have caused ripples backward in time, influencing earlier experiments and even preventing certain events from occurring. While this idea was highly speculative, it does raise the question, could CERN have uncovered evidence of time manipulation? If CERN discovered the potential for time travel, or even the ability to influence events in the past, it would be an enormously dangerous technology. The consequences of altering the timeline, even slightly, could be catastrophic. If scientists at CERN realized they had tapped into a force capable of changing past events or influencing future outcomes, it's possible that they would have been forced to shut down to prevent an uncontrollable disaster. Elon Musk, with his forward-thinking approach to humanity's future, may have realized the dangers associated with such a discovery. Time manipulation could threaten the very fabric of reality, leading to paradoxes, alternate timelines, or worse. One of the most profound and unsettling possibilities raised by Musk's statements is the idea that CERN's research may have uncovered evidence supporting the simulation hypothesis, the theory that our universe is a computer simulation. This idea, popularized by thinkers like Nick Bostrom and even endorsed by Musk himself, suggests that our reality might be an artificial construct created by an advanced civilization. If CERN's experiments produced data that pointed to glitches or anomalies in the fundamental structure of reality, it could be evidence that we are living in a simulation. For example, scientists might have detected inconsistencies in the laws of physics at extremely small scales or during high-energy collisions, suggesting that our universe behaves like a computer program with limits or errors. This discovery would be earth-shattering. It would challenge everything we know about the universe, existence, and our place in the cosmos. If CERN realized that we are living in a simulation, they may have chosen to shut down to avoid further destabilizing the system or attracting the attention of whoever, or whatever, created the simulation. Musk, who has expressed his belief in the possibility of the simulation hypothesis, would likely see this as both a revelation and a potential existential threat. If our reality is a simulation, then the beings or entities controlling it might not take kindly to us discovering the truth. Covering up this secret could lead to unforeseen consequences, possibly even the collapse of the simulation itself. Elon Musk has always positioned himself as a forward-thinking visionary, someone who looks ahead to the future and tries to anticipate both the opportunities and dangers that lie ahead. His ventures, from electric vehicles with Tesla to space exploration with SpaceX to his plan for colonizing Mars, are all driven by the belief that humanity must continue to push boundaries while being aware of the risks involved. Musk's interest in CERN's discoveries and his warnings about the implications of their experiments fit neatly within this narrative. As someone deeply concerned about the future of humanity, Musk may see CERN's research as both a tremendous opportunity and a grave danger. If scientists at CERN have indeed uncovered something that could threaten the existence of our universe, Musk might be using his influence to sound the alarm. At the same time, Musk is not one to shy away from taking bold action. If he believes that CERN's discoveries could be used for the betterment of humanity, whether it's the harnessing of dark matter, the opening of parallel dimensions, or even the ability to manipulate reality itself, he might see this as a chance to push humanity forward. Could Musk be positioning himself to step in and take control of the technology or knowledge uncovered by CERN? Given his resources and ambitions, it's not out of the question that he could fund further research into these areas, hoping to develop solutions that would mitigate the risks while unlocking the benefits of these discoveries. As the story surrounding CERN's shutdown and Musk's warnings continues to unfold, one thing is clear: the future of humanity is at a crossroads. If CERN has indeed made a terrifying discovery, the implications could be far-reaching, influencing not only the scientific community but the entire world. Will CERN resume its experiments, armed with new knowledge and a better understanding of the risks involved? Or will they permanently close the door on some of the most profound questions ever asked out of fear of what they might uncover? And what role will Elon Musk play in all of this? Will he continue to warn the public about the dangers of unchecked scientific advancement, or will he take a more active role in shaping the future of this research? As we await further developments, one thing is certain: the discoveries being made at the cutting edge of physics are pushing the boundaries of human knowledge to their limits. Whether these discoveries will lead to a brighter future or something far more dangerous remains to be seen. The only thing we can do now is hope that those pushing the frontiers of science, whether at CERN or in other labs around the world, understand the power they are dealing with and use it wisely. Because, as Musk has reminded us time and time again, the risks are real, and the stakes could not be higher. Originating from the collapse of massive stars at the end of their life cycles, tiny black holes might form through collisions of particles within CERN's Large Hadron Collider. These are different from the potentially Earth-engulfing black holes because they arise from the idea of additional dimensions beyond our familiar three-string theory. A complex mathematical framework suggests that these tiny black holes could materialize in 6 or even 10-dimensional spaces under extremely high-energy conditions. If these extra dimensions exist, they would be intricately coiled into minute loops within the space we currently know. The theory introduces the concept of gravitons, hypothetical carriers of the gravitational force, which are notably absent from the standard model of particle physics, leaving a gap in the understanding of forces at the microscopic level. Detecting gravitons could bridge this gap. Unlike traditional point particles, gravitons, like photons and bosons, are envisioned as minute ribbons or strings vibrating in distinct manners. These ribbons are thought to coil into tiny spheres of space measuring less than 10 to the power of -33 cm in width. Unfortunately, the dimensions of both the strings and these tiny coils of interdimensional space are beyond the measurement capabilities of tools like the Large Hadron Collider, as they are 10 million billion times smaller than what the accelerator can detect. If tiny black holes were indeed forming through collisions in interdimensional space, should we be concerned? There might be nothing to worry about, as Earth experiences daily bombardment by particles colliding with the atmosphere, generating energies over 100 million times greater than what the Large Hadron Collider can produce. It's plausible that these tiny black holes may already exist around us, but we are unable to observe them due to their inherent instability and brief existence. If they do exist, their presence would be so fleeting that it hardly falls within the conventional concept of time. Calculations show that these black holes have a decay time of 10 to the power of 83 seconds in our three-dimensional world, far beyond the smallest practical significance time scale, which is 10 to the power of -43 seconds. Another concern with massive particle accelerators is the potential danger of creating hypothetical entities known as strangelets. If these peculiar particles were to interact with the matter on Earth, they could condense it to the size of a soccer field. Understanding this process requires a grasp of matter's composition. All matter is composed of atoms consisting of 6 quarks, up, down, charm, top, bottom, and strange. Among these, only the up and down quarks contribute to the mass of familiar earthly matter, while the others rapidly decay into different substances. In the 1970s, physicists contemplated the effects of subjecting atoms to intense pressures and energies. In their models, atoms were pressurized to the point where protons and neutrons disintegrated into quarks. Under even greater pressure, up and down quarks could condense, with some transforming into stable, heavier strange quarks. If stability is achieved, strange matter is formed, which can disperse as strangelets, behaving like a viral force. Any matter these strangelets encounter would be drawn to their stability and mass, immediately converting into the highly compressed state of strange matter. Consequently, if a strangelet struck Earth, our planet would condense to asteroid size. A collision with the Sun would lead to the formation of a strange star, causing Earth to freeze. The notion is that strangelets could travel the universe, transforming everything they encounter into strange matter and turning the entire universe into a surreal rendition of Stranger Things. However, scientists at CERN insist there's no cause for alarm, as the Large Hadron Collider lacks the power to create the extreme conditions necessary for quarks to morph into stable strange matter. If strangelets and strange matter are theoretically possible, neutron stars are considered more likely generators. Under immense pressure, these incredibly dense stars, second only to black holes, could convert up and down quarks into strange quarks, creating strange matter that consumes the neutron star. A strange star from this process would exist independently, not infecting other celestial bodies. On the other hand, the collision of two strange stars could release strangelets into space, spreading like a cosmic virus. Another potential concern arising from particle collisions at CERN is the possibility of tearing open spacetime itself. According to some theories, the seemingly empty vacuum of space is more complex and fragile than commonly perceived. Theoretically, a sufficiently powerful particle accelerator could induce a phase transition, potentially ripping apart the fabric of space. While phase transitions, like the change of water between states, common, the idea that a human-made tool could unravel the framework of the universe has been firmly rejected. However, the forces at play in the cosmos operate on a scale far above our current capabilities. These forces include events such as the birth and death of stars, the brightness of quasars outshining entire galaxies, and the existence of supermassive black holes. These cosmic phenomena unfold on energy scales that exceed our reach, making it unlikely for us to replicate them through machines like large particle accelerators. As things stand, the concern about particle accelerators triggering the end of the universe might be overstated, at least within the parameters of their current designs. Such apprehensions could resurface in the future if we were to construct accelerators spanning the entire diameter of the Earth or the Sun, presenting challenges of a different magnitude. It is also crucial to acknowledge the perspective of experts like astrophysicist Martin Rees, who has stated that these apocalyptic scenarios are highly improbable, at least for now. The scale and complexity of cosmic phenomena and our current technological stage represent huge limitations, providing assurance that the potentially catastrophic outcomes attributed to particle accelerators are, for now, confined to the realm of speculation. Meanwhile, another enigma called dark matter unfolds within the silent story that plays out within the cosmos. This prevalent mystery evades scientific inquiry's understanding. Its presence is undeniable as it acts as a silent observer in the cosmic scene, yet it continues to elude detection. Could it be the key to unlocking the secrets of the universe, concealed within the whispers of unknown particles scattered throughout the cosmos? The quest for answers continues, driving the relentless pursuit of knowledge into the depths of the unknown. Within CERN, a small group of hopeful scientists has been on the edge of anticipation, longing for that pivotal moment when the collision of particles yields a revelation. This new entity is believed to hold the key to unraveling the elusive mysteries of dark matter. The prevailing theories revolve around microscopic particles existing in astronomical quantities across the cosmos, yet eluding detection by our current instruments. Among the contenders, the axion particle emerges with a speed that seizes the scientific imagination. Uncharted realms of theoretical particles lie within the standard model governing the 17 fundamental particles that make up our universe. Proposed nearly half a century ago, axions stand as prime candidates for the elusive dark matter. As particle accelerators increase in power and approach the realm of the unknown, axions gain more prominence in the quest for understanding dark matter. A turning point emerged in Tokyo a few years ago in 2020, when findings hinted at the first direct evidence of axions, casting a flicker of light into the dark expanse of uncertainty. Now, at the LHC, scientists diligently engineer tests calibrated to unlock the secrets of axions, enabling direct detection for the first time. The accelerators at CERN set the stage. They are colossal rings propelling subatomic particles at speeds nearing that of light. The particles, coerced into a collision course, come together powerfully, birthing an explosive release of energy. Amidst the chaos, fundamental particles scatter, providing a glimpse into subatomic interactions and possibly the long-sought revelations about dark matter. A startling anomaly emerged in the particle acceleration and collision storm, catching scientists off guard. A peculiar entity arose among the fragments of collided protons, a particle bearing the weight of a heavier, unfamiliar strange quark. Could this unexpected revelation herald the dawn of new physics? Quarks, the building blocks of matter, reveal a new level of complexity beyond expectation. Beyond the familiar up and down quarks lies a spectrum of flavors: charm, strange, top, and bottom. While the traditional trio of quarks forms the backbone of particles like protons and neutrons, the LHC paints a broader picture, unveiling novel combinations previously unseen. Recently, thanks to advancements in particle accelerators, researchers have made significant discoveries related to pentaquarks and tetraquarks, particles with configurations of 4 and 5 quarks. Following the latest run at the Large Hadron Collider, scientists identified 3 new variations of these particles, often referred to as exotic particles. Despite their temporary nature, existing for a mere fraction of a second within a 100,000th of a billionth, these exotic particles play a crucial role. their transient existence could shed light on the events that occurred at the beginning of the Big Bang. As scientists continue to observe more instances of these exotic particles, they aim to construct a periodic table for them. Engaging in this pursuit offers the potential to deepen our understanding of the minute forces that intricately mold the fundamental nature of existence. Consequently, although the Large Hadron Collider is unlikely to usher in the demise of the universe as we understand it, it serves as a valuable instrument in resolving the enigmatic origins of the cosmos. As the laboratory hums with excitement, a pivotal question lingers: do these newly discovered particles obediently align with the pre-existing architecture of the Standard Model, or do they signal an imminent disruption poised to redefine our understanding of the cosmos? This question evokes memories of the significant events of 2012, marked by the exciting discovery of the Higgs boson, which solidified the Standard Model after years of anticipation. The Higgs boson, often referred to as the God particle, is a subatomic particle that gives other particles their mass. First proposed in 1964 by Peter Higgs and other physicists, it was finally discovered in 2012 at CERN. The Higgs boson is thought to be the final piece of the puzzle in the Standard Model of particle physics. It is a crucial particle believed to be the cohesion of the universe. Without it, mass would not exist, and the cosmos would look radically different. Although the media dubbed the Higgs boson the God particle, this is a bit misleading, as the boson is not a god and does not explain everything in the cosmos. It is only a fundamental particle that plays a crucial role in imparting mass to many other particles in the Standard Model, facilitating the universe's existence in its current form. Despite its confirmatory status, recent discoveries cast shadows on the theory. As the LHC continues its progress, the desire for validation grows stronger. The elusive confirmation we seek slips through our grasp, leaving the entirety of the Standard Model veiled in uncertainty. As the mysteries of the universe gracefully unfold, they beckon us into uncharted realms. One resounding question echoes: what lies beyond? Within the experiments of the LHC, amid the frantic collisions of particles, the answers drift so near yet remain elusive. In this unfolding saga, each revelation pushes humanity to the edge of a new era in physics. The cosmos, a canvas of secrets, unveils its wonders in our pursuit. We inch closer to unlocking the profound mysteries that have lingered in the shadows of understanding within the framework of the Standard Model. A captivating but unverified concept called supersymmetry also takes center stage. It is a proposed symmetry between fermions and bosons. This theoretical framework anticipates the existence of partner particles for each known particle, bridging significant gaps within the model. For decades, the minds at CERN have tirelessly engaged in the quest to substantiate this unreachable symmetry. The stakes are astronomical. The confirmation of supersymmetry will be one of the monumental scientific revelations in history. The search for concrete evidence unfolds like a gripping story, with scientists navigating the maze of experiments and data analysis. The question looms: when will the elusive clues emerge, pointing toward an answer? As the excitement builds, scientists eagerly await a breakthrough that can redefine our understanding of the universe's fundamental forces. The timeline is uncertain, but with every experiment, hope and enthusiasm echo down the corridors of scientific inquiry. The anticipation is real, keeping the scientific community on the edge of their seats, yearning for that pivotal moment when evidence will unlock the secrets of supersymmetry.